Hello friends, in today's question, an organ pipe P1 closed at one end vibrating in its first harmonic and other pipe P2 open at both ends vibrating in its third harmonic are in resonance with a given tuning fork. The ratio of the length of P1 and P2 is. So we have two organ pipes. One is, you can say, open close. Another one is open, and we are going to find out the ratio of their lengths. So let us start with our first case, which gives us that we have an organ pipe P1 and let us call this as, because it is closed at one end, so we are going to call it as open close, because it will be open at one end and closed at the other end. And it is given that it is vibrating in the first harmonic. Vibrating in its first harmonic, or we can also say as a fundamental frequency. Fundamental frequency. And because it is open at one end and closed at other end, it is going to have, you can say, node at the closed end and antinode at the open end. Therefore, it has node at closed end and antinode at open end. So if lambda 1 is the wavelength, for wavelength is equal to lambda 1 and L1 length of P1, so we can write that our L1 is equal to 4 times, lambda 1 is equal to 4 times L1, and from here we can write our F1 because it is at your, you can say, first harmonic. So F1 is the representation of the first harmonic, that will equal to V upon lambda 1 rather, substituting value of lambda 1, we can write this as V upon 4L1. Similarly, we are going to find out what will be the frequency of the third harmonic for the second pipe, which is open at both ends. Organ pipe P2, and it is open. So it is open at both ends, and it is given that this pipe is vibrating at third harmonic. Vibrating at third harmonic. So both, as it's open at both ends, it is going to have antinode at both of ends. So you can say in open pipe P2, will have antinodes at both ends. Antinode at both ends, and it is given it is vibrating in the third harmonic. So therefore we can say that the third harmonic has 3/2 wavelength within the pipe. Third harmonic has 3/2 wavelength within the pipe. So wavelength, if we say, is our λ3 for third harmonic. So we say λ3 is the wavelength, L2 is the length of pipe P2. So therefore we can say our λ3 will be equal to 2/3 times L2, and from here we can find out frequency of the third harmonic F3. That will be equal to V upon λ3, and this gives us 3/2 V upon λ2. And in the question it is given that they are resonance for a given tuning fork. So it means both F1 as well as F3 will be same, because we are using the same tuning fork and the resonance frequency will be same. So we can say from here that since both pipes are at resonance for same tuning fork, we can write our F1 will be equal to F3. We substitute the values. F1 was our V upon 4L1, and F3 was our 3/2 V upon L2. V and V cancels out, and we are supposed to find out ratio of length of P1 and P2. So we are supposed to find out, this goes by 2, and we are supposed to find out what will be our L1 upon L2. L1 upon L2 will be equal to 1/6. Okay. So this is the ratio of length, of P1 and P2. So the options that are available to us, option number C is the correct option. So we can say option C is correct. So this completes the question. Thank you.